You can think of large language models as these sort of generic geniuses. They're amazing, right? They know a little bit about pretty much everything. But what happens when you don't need a generalist? What if you need a true world-class expert for one very specific job? Well, that's exactly what we're going to break down. How you can transform these brilliant all-rounders into highly focused specialists through a process called fine-tuning. So let's just jump right in with a question that kind of gets to the heart of everything. For the longest time, the thinking in AI has been that bigger is always better. More parameters, more data, more computing power, that's the only way to go. But is that really true? So what does the data actually say? Well, it's not even close. And what you're looking at here, this chart, it tells an incredible story. For a very specific task, generating structured JSON, a fine-tuned Llama 2 model, a 7 billion parameter model, hit 93% accuracy. And the much, much larger GPT-4, it only got to 66%. So think about that. The smaller, specialized model wasn't just a bit better, it was 40% more accurate while being 250 times smaller. This right here is the power of specialization. Okay, so that really brings us to the core of this whole conversation. Why would you go to all the trouble of fine-tuning an LML in the first place? Well, it's all about that idea of moving beyond a generalist and creating a true specialist that's perfect for your needs. So let's get a clear definition on the table. Fine-tuning is when you take a model that's already been pre-trained on, a huge chunk of the internet, and then you train it just a little bit more on a smaller, really focused data set. I love this analogy. Think of a medical student who's learned all the general medicine stuff. Fine-tuning is like their residency, where they go on to specialize in something very specific, like neurosurgery. They're not starting from scratch. They're just becoming an expert. But here's the thing, fine-tuning isn't the only way to do this. There are actually a few different ways you can adapt a generic model, and it's super important to pick the right tool for the job. Okay, first up, the simplest method by far is just prompting. This is basically what it sounds like. You just give the model really clear instructions in plain English. You're not actually changing the model itself, not at all. You're just getting really, really good at asking for exactly what you want. It's perfect for quick tests and prototypes, especially when you don't have a lot of labeled data to work with. Next up, we have something called Retrieval Augmented Generation, or RAG. This is where things get really cool. Imagine you could give your LLM a library card to your own private library of documents. When you ask it a question, the model first zips over to that library, finds the most relevant document, and then uses that fresh information to build its answer. It's an amazing way to use up-to-date or private information the model has never seen before. And that brings us right back around to fine-tuning. This is the heavyweight. This is the most powerful approach, because unlike those other two, you are directly updating the model's internal parameters. You're fundamentally changing its brain, so to speak, to make it a deep expert on your specific task. This is how you get the absolute best performance and efficiency. Okay, so this table just lays it all out, side by side. It makes the trade-offs super clear. You can see prompting is low effort, low cost, a great starting point. RAG is fantastic for bringing in new knowledge, but you need that external knowledge base. But look at fine-tuning. The key here is that little word yes under parameter update. It does take more computation, but it gives you the highest level of adaptation because you are permanently embedding a new skill into the model itself. All right, so you've decided, yep, I'm going to build a specialist. Now for what is honestly the most important part of this whole process, preparing its study materials. Because the quality of your finished model is 100% dependent on the quality of the data you teach it with. And this is probably the number one question people have, right? The one that makes them hesitate. How much data do I really need? It feels like you'd need a data set the size of Google's to make any difference. But is that true? Well, the answer is going to surprise you. It's way more accessible than you think. Incredible research from Meta showed that with as few as 1,000, just 1,000, high-quality examples, you can get fantastic results. Now, the key phrase there is high quality. It's not about quantity, it's all about quality. So what does this high-quality data actually look like? Well, it's pretty simple, actually. It's just a bunch of input-output pairs. For something like sentiment analysis, on the left, the input is the movie review, and the output is just the label positive. For a creative task like summarization, on the right, the input is a big block of text, and the output is that perfect, concise summary.
You're basically just showing the model over and over again. When you see this, I want you to produce that.
But I can hear you asking, that's great, but what if I'm starting from zero? I don't have any labeled data. Don't worry, you've got a couple of really great options. First, you can actually use a bigger LLM to generate synthetic data for you, basically creating thousands of new, perfect examples out of thin air. Or second, you can build what's called a data flywheel, where you collect feedback from your actual users to continuously improve your dataset and your model over time. Okay, your study materials are prepped and ready to go. Now let's get into the actual fine-tuning process. And trust me, thanks to some brilliant new techniques, you do not need a supercomputer for this anymore. We're going to look at some seriously efficient ways to get this done. And a tech that has completely changed the game here is something called QLoRa. This quote really says it all. It lets you drastically cut down on the memory you need while still getting the same great performance as a full fine-tune. This is the magic that makes fine-tuning so much more accessible today. I know, the name sounds super technical, right? QLoRa? But the idea behind it is actually pretty simple and frankly brilliant. It just smashes two clever ideas together. First is quantization, which is basically a fancy word for compressing the original model so it takes up less space. And the second is adapters, which are tiny, brand new little modules that you add to the model to do the training. So here's the play-by-play. It's so clever. First, you take that massive pre-trained model and you freeze it. You lock it down in a super compressed format to save a ton of memory. Then, you only train those tiny little adapter modules you added. So instead of having to change billions of parameters in the original model, you're only updating a few million in these new adapters. That's the secret. That's what slashes the memory and compute costs so dramatically. And just like that, the training is done. You've built your AI specialist. But now comes the moment of truth. Did it actually work? Is it any good? This final step, evaluation, is absolutely critical. We've got to put our new model to the test and see if it made the grade. And this is really important to get right. Effective evaluation isn't about chasing a single high score. It's all about figuring out what good actually means for your specific project. You have to define what success looks like for your use case before you can measure it. There's actually a great little 3-step framework you can use for this. First, know your starting point. How did the original generic model do on its own? Second, after you've fine-tuned your new model, start grouping its mistakes into categories. Find the patterns. Is it too wordy? Is it making stuff up? And third, prioritize. Go after the biggest, most damaging errors first. That's the fastest way to build trust and make the model genuinely useful. And look, you've got a whole toolbox of methods to help you evaluate. You can use automated scores, you can create your own custom checks, like seeing if the code it writes actually runs, you can use standard academic tests, you can have real humans rank the outputs, and you can even have another powerful LLM act as a judge. There are tons of options. So, let's just wrap this all up. What's the big idea here? The main takeaway is this. Fine-tuning is the process that lets you turn a generic jack-of-all-trades AI into a powerful, efficient, and cost-effective specialist that's been perfectly tailored to your specific goals and your specific data. The coolest part of all this is that this kind of powerful technology isn't just for massive tech companies anymore. It's within your reach. The ability to create a true AI expert is here. And that just leaves us with one last, really exciting question to think about. What problem are you going to solve first?